because the possible outcome you can count on your finger. So since it is a discrete metric data, you can present it like this. Okay, frequency distribution of the parity, write down the values, and here write down the frequency of these values. Okay, you can also look at this example, frequency distribution of efficacy of biodegradable stunt with durable stunt. So this is the possible outcome: 1 stunt, 2 stunt, 3 stunt, 4 stunt, unknown stunt, or 0 stunt. And this is the frequency of these two categories. So you can see that this is again total number of lesion. What is the type of this data? So this data is again a discrete metric data. Now, you can also write down this cumulative frequency also. This column is the cumulative frequency, and then percentage cumulative frequency. Some people also present it like this again. So now you can look at this birth weight. Okay, now birth weight is a continuous data because the possible outcome you are not going to count on your finger. Now you can see it is written in this class interval. Okay, and this class interval is something, it should be homogeneous because it is a class interval. So similar kind of children should be fall into this category. So this is how this class intervals are written over here, and how many children are born between 1500 gram to 199 gram. So only 2 children are born like this. So in this way, you can present your continuous metric data in the form of table. Okay. Now similarly, just I shown you that how you can present your ordinal, nominal, discrete, and continuous data in the form of table. Similarly, you can also present them in the form of charts. And the first chart which are being over here, you can see it is a very famous chart, and its name is pie chart. So if your data is nominal or ordinal, means if your data is categorical, you can present it with the help of the pie chart. It is very you can also present your data if your data is categorical data with the help of the simple bar chart. Okay, now just just see the quality of the simple bar chart, that you have got a gap between the bars. The height of the bars is representing the frequency of the data. Okay, since these are the various categories, that how many number of patients who are there because of the fall, how many patients because of the crush, how many patients are there because of the motor vehicle crash and others cause of injuries. Okay, so in this way you can, so this is called the simple bar chart. If you have to compare the two categories, okay, level of physical activity and number of patient, this is the one group who are taking this much of drug, and another group who is taking the, so you can compare these and just check. So this is called as clustered bar chart. Now, why this bar chart is very, very much important for you? Because if your data is discrete metric data, for that also you should prepare this bar chart. Okay, because it have got discontinuity between 0 and 1, it have got discontinuity. So for this you should not prepare that histogram. For this you should prepare bar chart. So that's why I am focusing on this particular aspect, that if your data is discrete metric data, for that you have to go with the bar chart. And again, if your data is continuous metric data, for that you can go with the histogram. So you can see there is no gap into the histogram. It actually represents the continuous nature of the data. Okay, this particular graph, it is termed as bar box plot, and this is one of my favorite chart. Why? Because this actually illustrate lot about, because the role of the table and the graph is to describe data, because we are just discussing descriptive statistics. So you can see that this box plot is describing a lot about this data. Okay, here you can see on the x-axis there are two groups. One is the control and one is the non-agiospermic long-term survival of the childhood cancer. Frequency is being written over here, and this last column is the lowest value, and this top column is the highest value. So this is box, and this line is termed as whisker. So sometimes this is also termed as box and whisker plot. Okay, here I've written box plot, but this is box and this is whisker. Now this box, the top of this box actually represents the 75th percentile. It means 25% of the people have got values more than this value. Okay, more than 120 into 10 to the power 6 ml. So 25% of the people in this group have got value more than 120. Similarly, this is called the first quartile, and 25% of the people have got value less than 50. Okay, and this is the median of the data. So 50% of the values are below this and 50% of the values are above this. In this way, the reader is going to read your box plot. So it hides a lot of information for you. Okay. Now, since we are discussing about the graph and table, and usually the table which you observe into a research article is something like this. You can see the table, and you should also learn by the end of this workshop that how you can prepare this table. So the first column is actually the variables, and the second column is one group, the third column is the another group, and the last column is actually going to tell whether there is any significant difference between these two groups or not. The first characteristic which you are going to describe is number of participants. So in the breastfed group there are 149 participants, 67 are men and 82 are women, and in bottle fed group there are 182 participants and 93 are men and 89 are women. Now you can see another quality of this table, that whenever your data is metric data, unit are written in bracket. I didn't find anybody of you writing this unit so precisely into the table. You can see. So from this, the reader is able to understand that all these variables are metric data. Okay, because you have written the unit just in front of that particular variable. So this guides the reader that these are metric data. And smoking history, unit is not written. They are writing that we will just write down the number, and in bracket we'll just write down. And these are the three categories. Another one is the social class, and these are the categories. Okay, so these two are categorical data. So I'm just not observing the second and third column. I'm just observing the first column, and with the help of this first column, it is going to tell me a lot about my data which I have collected. Now, if you can see the height is written something like this, 170, and here in bracket it is written 10. Okay. Similarly, weight. For weight, it is written 70.4, and in bracket it is written 14.5. But for length of breastfeeding, now you can think of length of breastfeeding. So it is a continuous metric variable. So the value is 3.33. But here in bracket, they have written 0 to 18. Now, this is the story that why they have written 0 to 18. For height and weight, they have written 170. In bracket, they have written 10. But for length of breastfeeding, they have written 3.33 and 0 to 18. Why? What the reader should or what you should interpret from it. So the interpretation is that if you assume that your data is normally distributed, if you assume that your data is normally distributed about the mean, then you should present your data with mean and standard deviation. That's it. But if your data is skewed, if your data is skewed like this, it is not normally distributed, then you should present your data with median and range or median and quartile. Okay. So similarly, this is another example. Okay. Now, you have described the data with the help of table. You have described the data with the help of the graph. Now, how you can describe the data with the help of the number? In the previous table, you have seen that if your data is categorical, simply count the data and write down the percentage. That's it. Nothing you have to do. It will give you the information to the reader. Okay. But if your data is continuous and you want to summarize the data, okay, so one very less frequently used is the mode. You can calculate the mode, okay, that which one is coming the maximum time. So the example is that these are the 22 babies which are born in a hospital in last week, and this is the type of delivery. Okay, so what is the modal delivery method? So by looking at this, that which method is the maximum number of way out of these 22 babies things are born. So by this you can present the modal value. Okay. Now this mode is not very much popular into the medicine because instead of giving the modal value, people just write down all the possible values, and in front of it they write down the frequency, and in bracket they write down the percentage. Now another important descriptive statistics is a median. Okay, so what is median? So median is something that you arrange the data in ascending and or the descending order, pick up the middle value and say 50% of observation are more than this value and 50% of observation are less than this value. So that value is termed as median. Okay. So median is something which divides the data into two equal parts. So you can see this example which is being written over here, that if your data have got 5 individuals, 30, 31, 32, 33, 35, arrange them, and you can say that 32 is your median. Okay. Now, if your data is like this, that it have got 6 instead of 5, it have got 6. So for this, you have to take 2 middle values because you cannot take one value. Okay, you have to take 2 middle value and you have to take mean of these two. Okay, so it will be 32.5 is the median of this data. Now, if you move to the next example, instead of 36, if the one person is of 96, in this case also, the median will be 32.5. Okay. Now, why I'm quoting this example? Because of this quality of the median, we should learn that when we should use median and when we should not use median. Okay. So, now one more very important descriptive, numerical descriptive statistics is the mean. You all know the formula of the mean, that you sum all the observation and divide it by number of observation. Since class 8th or 9th, also this formula is being uh, given to you. But important thing is that when you should use mean and when you should not use mean. Okay. So when your data is normally distributed, then you should go for mean. Normally or close to normal distribution, then you should represent the summary of the data with the help of the mean. But if your data is skewed, okay, because of some outliers, the mean are going to get affected by it. And in the just previous example, if you calculate the mean of these two data, because of this 96, the mean is going to get escalated. Okay. So you just take one more example to understand that you go to a village and ask the average income of the villagers or the household in that village. So in that village, if there are 50 household, and you just start measuring the monthly income of these 50 household, you just inquired. So some of the household is responding that you evaluated 5,000, 7,000, 3,300, like this the observations are coming. But there are some houses for which the median is around more than 1 lakh. 1 lakh. Okay. So these 5 households are there whose annual income is more than 1 lakh. Some of them is of 2 lakh. And when you calculate the mean of this 50 household, you are going to get that average income of each household is 35,000. What the people will understand that this village is very much rich and very much successful. But if you calculate, if you arrange the all the data in ascending or descending order and tell the median, so median is around 7,000. So you will say 50% of the people are living below 7,000. And with the median also, you can also tell the quartile that 2,000, that 25% people income is less than 2,000, and 8,000 is the third quartile. So you can say that only 25% people are above 8,000. What is mean? Mean is 35,000. So it depends upon the data that which numerical summary you should present. So if your data is skewed, you should go with the median and quartiles, or median or range. And if your data is not skewed, it is normal, then you should go with median. That is what also I'm telling in this example. Length of breastfeeding. Length of breastfeeding is not normally distributed. So they have given the median 3.33, and also they have given the range. But for height, they have given 170 meter, this centimeter is the height, and 10 centimeter is the standard deviation. Okay. So to summarize this measure of location, so you can see type of variable. So type of variable, it will be either nominal. So if your variable is nominal, you can see, you can calculate the mode, but you cannot calculate the median or mean. It is irrelevant to calculate the median or mean. If your data is ordinal, so mode you can calculate, median you can calculate, but mean you cannot calculate. It do not make any sense to calculate the mean of the ordinal data. Similarly, if your data is metric discrete, okay, so you can calculate the mode. Yes, median is calculated only if your data is skewed, or you can also go with the mean. Mean you can calculate. Similarly, if your data is metric continuous, mode you cannot calculate. If your data is metric continuous, mode is irrelevant. And median or mean you can calculate accordingly. You have to decide whether your data is skewed or it is not skewed. Now, until now, we were discussing about the measure of location. Now we will discuss about measure of dispersion, that how much your data is scattered. The very simple thing that you can present is the range. Just present the minimum and maximum value of the data. It will give the reader an idea that in what range the people are distributed. Now the question is again, what if outliers are present? So if outliers are present, you can go with the quartiles. Okay, you can present your data with the help of this quartile Q1 and Q3, and Q2 is actually median. Okay, so you can present your data with the help of the quartiles. In the box plot also actually presents these quartiles. Okay, this is the simple way to describe the quartile. Now you do not need not to manually do this. With the help of box plot also, you can give the dispersion of the data. That's why I'm saying that this box plot is very interesting plot, because it describes the data. It gives you the mean, it gives you the quartiles, so dispersion of the data. So this gives you both things. Now, one more very important measure of dispersion, how data is dispersed, how much variation, how much variability is to the data, is measured in terms of variance and standard deviation. Now, if you look at the simple mathematics behind obtaining the variance, so just look at these example. So there are 5 employee in a particular office, and their age is like this: 23, 34, 36, 30, and 29. And you want to calculate the standard deviation, how much variability is there in this data. So the idea is that just calculate the mean. The mean comes out to be 30.4. Add all these observation and divide by 5. The means comes out to be 30.4. Okay. Now, if you just measure the distance of all these observation from the means, and find out average distance, so it will give you an idea about that how much variability is there into the data. Now, when you do this, find out the difference. So some of them are positive, some of them are negative, and whenever you add all these difference, every time you are going to get 0. So this is the property of the mean, that it will subtract all the observation from the mean and sum them, it will be 0. So the idea fails. Now what they do, they just square it, square this distance, the difference between the mean and the individual data point. So they just square it. Okay, by squaring, all the negative also become positive, and then they calculate the sum, and then this, when they divide it by the total number of observation, it is termed as variance. So variance is nothing but this xi represents all the observation, the distance between all the observation from the mean, just square it, and after that divide it by total number of observation. Okay, so this will give you variance. This is the formula of the variance. Since you did this, so you square it, so again you have to take the square root of it. Okay, again you have to take the square root of 20.24, and it will give you 4.45. So this is nothing but standard deviation. So this is the relationship between variance and standard deviation. Again, you have to remember that if your data is nominal, you cannot calculate the range, you cannot calculate the interquartile range, and you cannot calculate the standard deviation. Okay, if your data is ordinal, you can calculate the range, you can calculate the interquartile range, but you cannot calculate the standard deviation. Similarly, if your data is metric, either it is discrete or continuous, you can calculate the range. You can go with the interquartile range if your data is skewed, and you can go with the standard deviation if your data is not skewed. Okay. So the summary of this talk is that, again, I reiterate it, that if your data have unit, you will say yes, it is metric. Data have unit, you will say no, it is categorical. Categorical data is percentage in terms of number and percentage. Metric data is presented in terms of mean, standard deviation, or median with quartiles. Now, when metric data is presented with the help of mean and standard deviation, if your data is normally distributed. When your data is presented with the median, if your data is not normally distributed, it is a skewed data. Okay, then you should go with the median and quartiles. I have given the example of this income data. Okay, so I'm not going to discuss my further slides, because I have to also discuss something on the SPSS also. So at this particular point of time, I would like to invite few questions from this lecture, and then I will go for the practical session.
Hello, sir.
Yes, yes, please tell me.
I have one question. So you are using mean and standard deviation. Why not standard error?
Standard error is something different from the standard deviation. Okay, standard error is I think in the tomorrow lecture they will also explain you in detail. But standard error and standard deviation are two different concepts, two different things. When you estimate something, so you are going to get a, for example, just the example which I was showing, that you want to estimate what proportion of children are suffering from asthma. You just recruited 100 children and interviewed them, and you find out the value comes out to be 19. Okay. Hello.
Yes, sir. Yes, sir.
And if somebody again, if somebody else is going to do the same thing, or if you are going to measure the average weight of the children of class 5th, so you are going to get some values around, say, 25 kg. And if somebody else is going to do the same experiment, so he is going to get another value. He may get 20 kg, another he may get 22 kg. So the estimates are changing as per the sample. So in this case, what is happening? You are saying that this is my mean value, and the error which is there in my measurement is termed as standard error. Here you are simply describing the data, that I have collected the data of the 50 children, mean is this and standard deviation is this. That standard error will come when you will talk about the estimation part. Tomorrow it will be discussed, I think. So you will again be with this confusion. Tomorrow the speaker will explain you. But when you are going to describe the data, you have to give mean and standard deviation given your data is normally distributed.
So I also have a okay. So I also have a question, sir.
Yes.
Whenever there is a table and median is described, and you also showed a table in which there was a median, and in brackets there were some number which were mentioning the range. But later on you said that usually we should describe the interquartile range. So what is the ideal way to mention in the brackets, interquartile range or the complete range?
If your data do not have much outliers, so you can go with the that range. But if your data is containing outliers, then you should go with the interquartile range. Means in that case, the maximum or
Can
the
you
minimum.
simplify your statement, sir? Yeah, it will.
Yes. I'm simplifying my statement. If you heard my example of that income, if you are going to say that 7,000 is the median value. The range is 500 to 2 lakh. Another statement, 7,000 is the median value, and first quartile is 5,000 and third quartile is 8,000. Now, reader in which have got reader got maximum information?
I
First
think
one or second one?
First one, sir. If he's being told that, shouldn't he come to know that the range was so much variable?
No, the second example, because he came to know more than 8,000, only 25% people are there.
Okay, sir. So it means if there are more number of outliers, then interquartile range should be used.
Yes. In that case, you should go with the interquartile.
So more outliers, interquartile range, less outliers, the whole range should be given.
Even one outlier is there, you should go with the interquartile range, because that outlier is going to, because what is the range? Maximum or minimum value? Outlier is there, so it will just tell that this is the maximum value.
It will confuse the reader, basically.
Yes. So it is better to go with the not interquartile range. It is better to go with the quartiles, because it gives more information. It describes the data better.
But sir, in that case, shouldn't the table be mentioning that what we are talking about? Because like in that table, they did not clarify what they are giving.
No. Actually, they have just written that you should write down the star, and at the footnote you should write down what actually it is.
Understood, sir. Understood. Yes. Thank you, sir.
Sir, yes. And you talked about the nominal distribution. So if there are about 10 data, I will know the outliers. But in case there are a huge number of data, how should I know how should I know that my data is having a bell-shaped curve, or whether it is skewed data? What are the ways in which I can test?
I will answer this question into the practical session. That because in SPSS, I will tell you how to test the normality of the data. Valid question. I will answer into the practical session.
You, sir.
Sir, I have a question.
Yes.
So how do we summarize any data which is on a Likert scale?
The Likert scale data is basically the ordinal data. Okay. So you should go with median, and median is the best way to compare between two groups. Okay. Yeah.
So median along with the interquartile range.
Yes.
Median with
not interquartile range. I am not preferring interquartile, because interquartile range again simply the difference between Q3 and Q1. Yes, you should give median, and with median you should give that Q1 and Q3.
Okay. Thank you, sir.
So can you again explain the ordinal data?
Yeah, even I want to know about the ordinal data.
Sir, please explain about skewed data.
Yes, I will be explaining skewed data into the practical session. Now, ordinal data is something, the data do not have any unit, but it have got ordering. It is a categorical data, but the categories are, you can order in the categories. But what is the difference between these categories that you cannot elaborate? Okay, this is the ordering. Means what I tell you, when you measure something, you can associate a unit with it, or you cannot associate a unit with it. If you cannot associate a unit with it, it is a categorical data. Now, if the categories can be ordered, it has some sense in ordering the categories, then it will become the ordinal categorical data. Otherwise, it will be the nominal data. As I have given the example, when the patient comes to the COVID hospital, what is the status of the patient? The patient is on the room air, the patient is on the oxygen, or the patient needs intubation. Now, these are the three categories. But by knowing these three categories, the doctor have an idea that what is the severity of the patient who are coming to the OPD or into the COVID hospital. Okay, but the same patient, whether it's coming from urban or rural, this do not have any ordering into it. Okay, so this is the meaning. Categorical data, categories have got some order. But what is the actual difference between these categories that you cannot tell?
Excuse me, sir.
Yes.
So you give an example of like number of children a patient is having. So, sir, that doesn't exactly have any metric unit as such. So how is it?
It have 2 children. How many children? 2 child. It have got a unit with it on its back. How many child? 2 child. How many stunt? 3 stunt. Okay.
Sir,
So this, yes.
sir,
Excuse me, sir.
they're not very clear about the variance and standard deviation and the difference. I couldn't get it properly, sir.
Did you understand the variance?
No, sir, not very clearly, sir. The mean
Okay.
and what you have explained, I heard, but not very clear, sir.
Okay.
The same question here, sir. In a standard deviation,
Hmm.
should the denominator be n-1 because the sample size is less than 30?
No. This n-1 will come when you are talking about unbiased estimation of the standard deviation. And when we are talking about the estimating,
we have read this several times that if the sample size is less than 30, the denominator should be n-1.
No, this is a wrong concept. This is a wrong concept.
Okay.
This is really a very wrong concept. And let me tell you that today we are just we are in the process of describing the data. What you are telling actually is that look what we are doing. We are just taking a sample, and on the basis of sample, we are estimating the mean and standard deviation. Okay.
Yes.
Now, as the sample will change, this mean and standard deviation will change.
Definitely.
Third sample, the mean and standard deviation will change.
Yes.
Okay. Now,
Yes,
the thing is that what is the unbiased statistics of mean? So it is nothing but just mean. Mean is the unbiased measurement of mean. But for variance, you have to, instead of dividing by n, you have to divide it by 1 upon n-1. Then only it will be unbiased statistics of variance. Okay. So when you are just describing the data, you should just simply go with 1 upon n. That's it.
Okay.
Excuse me, sir. Can you explain the range?
Sir,
Range is maximum and minimum value. That's it.
Sir, regarding mode,
Sir,
excuse
one
me, sir.
question.
Yes.
Regarding
Sir,
the mode,
can I go ahead?
for continuous data, continuous metric data, is it possible to find the mode?
No.
It was, but
It is possible. No, it is possible.
Yeah.
It is possible, but it is irrelevant.
But it's possible. I think in practically it is possible, but through software, I think it's not available.
No. It is possible to you can get the mode of the continuous data, but it is irrelevant. इसका कोई जरूरत नहीं पड़ेगा. That is what the message is.
Sir, the number of children, if you take the number of children, for example, it becomes metric discrete data, right?
Yes.
But if you take a fertility rate like 2.1, 3.3, it becomes, it is not discrete, it becomes continuous, right?
Yes, it will become continuous.
In that case, we can't take mode.
In that case, you cannot take, look, this is the rate. And to club the rate, it needs quite different, that is harmonic mean you can go with. Because when you are going to club the rate for describing the rate, you should go with the harmonic mean. What I discussed today, I didn't discuss the harmonic mean.
Sir,
can you tell about interquartile range and whole range? When you are discussing about interquartile and whole, at that time we lost the connectivity. Can you?
I am not in favor of interquartile range. Interquartile range is simply difference between Q3 minus Q1. That's it. I am in favor of presenting your data Q3 and Q1. Do not present the difference between them. Just give the median and Q3 and Q1. you can, instead of giving a Q3 and Q1, you can give the maximum or the minimum if your data do not contain any outlier. That is my message.
Sir, if
Okay,
there is
sir.
no
Can you
outliers,
plan
then
systematic
the
variability,
distribution
please?
will be a normal distribution, sir.
Yes, again.
Can you please explain the planned systematic variability?
Planned systematic variability. Yes,
Yeah,
very
please.
valid question. For example, you want to measure the impact of COVID vaccination on
Sir, can you explain it in terms of agriculture? Actually, I'm an
yes, I
agriculture.
can explain it in terms of agriculture.
Yeah,
If you want to measure the impact of
maybe a fertilizer.
yes, impact of fertilizer on the outcome of a crop. Okay.
Yeah. Okay.
So you are just giving a different level of fertilizers into different blocks.
Yeah.
And you are measuring the outcome at the
Yeah.
end. At the end, okay. The size of the field and everything is there. So you are measuring the variability. You are measuring the variability because this is planned. You are planning. इसमें 50 gram देंगे, इसमें 100 gram देंगे, इसमें 150 gram.
Sure.
Okay. So the variability is planned. But sometimes what happens, not only the fertilizer is there because by which the output is there.
Okay.
The quality of soil, how much irrigation you are giving to this. Maybe one land is getting more irrigation and two land is not getting so much of irrigation. One land is under the shadow of the tree, another two land is not under the shadow of the tree.
Or maybe soil fertility
so variability can creep in because of the unplanned segment.
Okay.
Sir, can you give some example
Thank you,
related to standard error in terms of clinical data?
Standard error, boss, something is like that. I tell you, this standard error is coming so many times. Let me just.
तो पेपर्स में तो ज्यादा स्टैंडर्ड एरर ही यूज होता है ना सर?
नहीं मैम, मैं उसको क्लियर कर दूं तब आप लोगों से फिर बात करूं, क्योंकि ये बड़ा ही
सर पर वी कैन रिमूव द आउटलायर्स, है ना?
Yes, we can remove the outliers given our information doesn't we doesn't lose the information. I have got that particular. Just let me share one figure with you people. Yeah. Can you look at this particular figure?
Or sir, we use the standard error for population parameter. Or
Yes, sir. It is visible.
Let me explain this figure, then
yes, sir, it is visible.
Okay, you can just think of that. This is the employees of institution, and measure. Just unmute mute yourself. You want to measure the what you can say average height of the employee of your institution. Okay. Now the question is that you take a random sample of these are the 1,000 employees, and you take a random sample of size n, of size 50. Okay. From this 1,000 sample target population, you take a random sample of size 50, and in that you measure the average, and it comes out to be 152 centimeters. If you again repeat the same experiment, the average height comes out to be 161. If you again take the the average height comes out to be 159 centimeters. Now you can see that as the sample will change, the average height is going to change. Okay. So this means from the population, you are taking the sample and you are estimating the average height. You are estimating the height. But while doing this process, you are committing an error. Because the actual sample size, it can be 152 centimeters. But when you are doing, it comes out to be 161 centimeters. So actual samples, you are committing an error, and you want to measure this error. you want to measure this error. Okay. So this error, do you understand what error you are coming? You are doing a sampling error, because yes.
So what we should understand actually is that standard deviation, suppose we have a sample or we have a population, standard deviation is a measure of variability.
Yes.
Around the mean in
Yes.
that particular population.
Yes.
And standard error is, if we repeat such experiment multiple times, how much will be the variability in the different means we get?
Yes. That is
the standard error.
Yes.
So
That is actually.
there are two different things. So
yes,
in most of the papers, standard error is depicted because they want to see whether our experiment was reliable or not. So we have to depict standard error also. But for our particular like population in which we are working, for descriptive work, we need standard deviation also.
When you are, yes, that is what actually I want to tell. When you are in the phase of describing the data, when you are preparing the you can say baseline table of your data, at that time you should not go with the standard error.
Yes.
At that time you should simply give the mean and standard deviation, because it will tell in your sample how much data is varying. And this standard error actually is measuring that what you have measured, how much error is there. Okay, so this standard error actually measure what is the error into your data. So again, tomorrow this standard error will be discussed and it will be explained to you people.
Sir? Hello.
Yes.
Excuse me, sir. Standard error actually it defines the external validity of the data or not, like whether the data is...
Standard error actually measures the you can say precision of the estimate. How your estimate is, how is precise your estimate is. If there is a lot of variability into the standard error, it means your estimate is not precise.
Okay.
Sir, excuse me, sir.
How we can find the pooled samples standard error?
Pooled sampled standard error.
Sir, for which data we use box? Is it audible, sir?
Yes, again, which data?
Sir, for which data, like you already taught about nominal data, ordinal data. So for which data we use box plot, sir? Box whisker plot.
Box plot, we can go for this metric data. We can prepare it for the nominal ordinal data. For these two, we can prepare the box plot.
Okay, sir.
And it will be better if our data is skewed. Box plot is the better representation. But if your data is continuous, no need of the box plot, because we think that our data is symmetric.
Excuse me, sir.
Yes.
Sir, I have... Hello, am I audible?
Sir, please explain the variance and the standard deviation. I was still confused, sir.
Yes, variance and standard deviation. Variance is the measure of all the points from the mean. You just square it, and then you just take the average of it. Okay.
What is the significance, sir?
By this, you are measuring that how much variability is there into the data. आपने क्या किया? आपने सारे observations को mean से distance निकाल लिया. अब देखना average distance कितना है.
सारे values का. जी sir.
सारे values को you just subtracted from the mean. And जब आपने sum किया तो 0 हो गया, तो इसके लिए आपने क्या कर दिया? Square कर दिया.
Yeah, sure, sir.
And square करने के बाद then you have taken the average distance. तो आपको पता कि डेटा में कितना फैला हुआ है. Means how much data are deviating from the mean. What is the average distance of the data? Squared average distance of the data from the mean. तो इससे आपको पता चलता कहाँ पे डेटा मीन्स के ज्यादा पास है, कहाँ पे डेटा मीन से ज्यादा दूर है. अगर वेरिएंस ज्यादा है, इसका मतलब ज्यादा दूर है. वेरिएंस लेकिन क्योंकि आपने स्क्वायर किया था, because you have squared it, so again you have just taken the square root उसको उसी में लाने के लिए. So this is the difference between variance and standard.
Excuse me, sir.
Yes.
And the standard deviation,
sir? Sir, actually, I have 50 total patient sample. Actually,
listen, let me explain something on the SPSS also, because it is very important.
Sir, one last question, sir.
Yes.
Yeah, we can
Sir, I
take
have
questions in
50
the last
total samples.
after this
I will take
hands on because we
question
are running late.
the last.
We will take
The last
questions in the
last
last.
one.
Sir, how does standard deviation
Sir, I
affect
have
validity?
50 samples.
Please,
Among which
yeah, I will answer your question.
Excuse me,
Don't.
sir?
I will answer your question.
Please put your questions with us, and after this hands
I
on,
will answer the
again,
question.
we will
Let-
again.
because the time is running now. So one of the motive of this talk
Sir,
is
one
to
last question. Sir.
No, there is no problem now. You have time. Don't worry. And I think more of your questions will be short out during the hands on session. So please continue, sir, with the hands on.
Okay, so can you give me to share this? Is yes. Share. Now I have converted this into 1 or 2, that string into numeric. After that, I have to change the type from string to numeric. Okay. After that, I have to change the value. One stand for SPONT and 2 stand for IVF. Okay. And then click OK. And you can see in the data view that again this data is now a final data. Okay. Now you can see what is actually happening here. This age at admission. Okay. Age at admission. So this is the data, and this data actually in days when the baby is admitted to the hospital. What is the age of the baby at the time of admission of the baby? So you can see data, it is written 1111 like this. But what is the this type is numeric. But what is the level of measurement? Level of measurement is given as nominal. No, it should not be nominal. It should be scale. It is a scale data. So you have to do like this. Okay, it is a scale data. Similarly, gestation age at week, it is a scale data. Birth weight, it is a scale data. AGA, SGA, steroid, again these two are string nominal. You have to convert it into the nominal the way I have told you. Now, this is your data set. Now you want to summarize this data set. So for that, what you have to do, that you should go to the descriptive statistics and go to the frequency, and in the frequency you just put all the categorical variable like this. Okay, and then click OK. So from here you can see the frequency and the percentage. So you can write down these results into your Excel sheet. That will represent that out of 67, 73% are AGA and only 26% are SGA. How many of them are taking steroid? So around 60% do not taken any kind of steroid, and 40% of them have taken steroid. So in this way, these categorical data, with the help of number and percentage, you can put it. Now, again, the question is what we should do with this metric data. Okay, so we have got 3 metric data. Now, what we should do? So in my lectures, I told you that if your metric data is skewed, you should go with the median and interquartile. And if your metric data is normally distributed, so you should go with the median and standard deviation. Now we should check whether our data is whether our data is normally distributed or skewed. For doing this, we should go to the analyze, descriptive statistics, and then go to the explore. Okay, and then select your dependent list. Okay, so I'm selecting these 3. I'm selecting all these 3 lists, and then I'm going to click on this statistics, and this is the descriptive statistics, and confidence interval for mean will also give. Okay, then I will go to the plots. So I want histogram. Okay, and here it is given normality plot with test. So I will normality plot with test, then continue, and then in the option nothing will change, and display I want to display both. So for these 3 variables, it will display the descriptive statistics, histogram, and normality test. Then I will click OK. So when I will click OK, it is going to give all the descriptive statistics of all these 3 variables. You can see 8 age admission, the mean is 7.52, and the median is 4 days. Mean is 7.52, median is 4 days. Now what is the range? Minimum is 1, maximum is 38. Okay, interquartile range is 11. Skewness is this and curses is this. As I didn't discuss skewness and curses, so I've not. And you can see that. Yes. So standard error is also being calculated, but you should go with mean. And here you can see standard deviation is you should not go with the standard error. Okay, you are going to describe the data. Now, whether we should use mean with the standard deviation or we should use median with range or interquartile range. So for that, you should just look at the normality of the data. So you can see that these three, null hypothesis is that data is normally distributed. Okay, so the data is normally distributed. So this is rejected. Gestation age at week, data is not. This is also rejected. Birth rate, you can see it is somewhat also very much close to the rejection. You can see the histogram of age at admission. It is not normally distributed kind of data. You can see that most of the patient baby who are admitted to the hospital, their age is quite less. So this is a skewed data. Okay. Again, you can see the box plot of this. If the box plot is not symmetric, this median is not lying into the middle of it, and it is also a representation of that data is. You can also see that station age at week. This is also a skewed data. Okay, this is not normally distributed data. And similarly, the birth weight. Birth weight is also a very different kind of data. It is not a normally distributed data. So what we should do now? Again, the question is that what you can see this histogram. The birth weight is very close to the normal distribution. So for birth weight, you can give mean and standard deviation. But for another two, you should not give mean and standard deviation. You can see there are lots of outliers which are sitting over there. Now with this, again go to the analyze descriptive statistics. Here you can see frequency, or you can go with this explore. Okay, and show the statistics only. In statistics, I want percentile because I want Q1 and Q3. So I click the percentile. I want the outliers, so I also click the outliers and then click T and then click OK. Okay, so it is going to give me the percentile. You can see the quartile for age at admission 1. It means 25% of the patient have 1. What is the median? 4. 50% of the patient when they are admitted to the hospital, their age is 4. And 25% of the patient they are admitted to the hospital, their age is more than 11. Similarly, gestation age at week 34 is the 34 week is the 25% of the babies are born below 34 week, and only 25% of the babies are born above 37 week. Similarly, for birth weight, 25% of the babies born with 167 years. So this is how the people is reading, describing your data. The mean and standard you can find out from here, and percentile you can find out from here. Now these are the extreme values. These are the extreme values at age at admission. Serial number 67, 23, 60, 61, and 26. You can see the extreme values for your extreme values. Now you can just remove if this is it is going to affect your data analysis. Similarly, the lowest 5 lowest value. Similarly, for gestation age, 5 highest value and 5 lowest value are being given over, and birth weight 5 highest value and 5 lowest value are given for you. Now you from here you can decide as a principal investigator that what is my outliers and whether we should keep it for further, we should keep it for analysis or not. Okay, so this is all about describing the data. And if you go to the graphs, and here you can see I have discussed the bar chart, simple bar chart, define. I want to prepare the bar chart for this Okay. So it will just simply give me the bar chart whether the patient is inborn, count is here. Similarly, if I want to prepare the pie chart, spontaneous, because it is only 2 categories, so pie chart will be something like this. But if there are more than 2 categories, so pie chart will explain more about it. And one more graph is box plot, simple box plot, just define it. I want to see the box plot of age at admission. Okay. This is the variable age at admission. I want to see its box plot. And I want to see whether the age at admission is going to depend upon whether the patient is inborn or outborn. So you can see that this is the box plot for these 2 categories also. Graphs in this way in SPSS, graphs are being prepared for you. Histogram is there. If you want to prepare the histogram for birth weight, just click OK, and it will give you the histogram of birth weight. Okay, so in this way, you can just go with preparing the charts and graph outliers. You can check whether your data is normally distributed. For that, again, I will tell you, go to the analyze, descriptive statistics, explore, and in explore you should go with the statistics, then click, and then go into the just cancel. Just a minute. Cancel, reset. I'm just taking this variable and I am just going to the plots. Now in the plots, you can see normality plots with test. Okay. And then I will click OK. So what it will do, actually, it will just test for normality there. So there are 2 tests. One is the Kolmogorov-Simrov test, another one is the Sapro-Wilk test. These both tests, the null hypothesis in these both tests is that my data is normally distributed. And if it is coming insignificant, so you can say that null hypothesis is rejected. It means your data is not normally distributed. So if your data is not normally distributed, for this you should present median with quartiles. Okay, so this is the way you should present your data. Okay. So I will stop here, and again I will invite the question for this presentation if any confusion is there. Actually, for testing of homogeneity, you should go with this mean, and then in the one-way ANOVA. And if you want to just want to test whether the gestational age at week have something to do with the spontaneous IVF, and then go to the post hoc. And here in the post hoc, you want to test whether your equal variance is assumed there or not. So how to do the post hoc into this SPSS? And so test of homogeneity is mean both the data are coming from the variance is both the variance is equal in both the data set. So this is the way to test the homogeneity, and I think there is no direct way to test the homogeneity of the data into the SPSS. I may not be sure that how to test the homogeneity into the SPSS directly. Formulas are there. I didn't discuss that, but request Dr. Dharmen to do it in some other session. Right now, I'm not remembering how to do this test of homogeneity into the SPSS directly. It may be there. I have got some another session, so I will try to explain in that. Any another question? Yeah. Yeah, anybody can unmute and ask the question. So regarding this practical presentation. Am I audible? There are lots of question actually, and sir, you are running too fast. Sir, can we make nomogram? No, nomogram is very difficult to. Dr. Dharmin, can you let the participant to unmute and ask them question? So the question is that how to convert this. I'm doing it for this AG and SGA because you can see when I'm just clicking on this number, this is changing numeric to label. This is changing, but this AG and SGA is not changing. Okay, because it is a nominal variable. It is a string nominal variable. Okay, so we have to convert it into the numeric. For this, what we have to do, just go to the analyze frequency and reset. I want to just see what are the outcome. So AG and SG. So I will code AGA with 1 and SGA with 2. So I will go to the transform, recode into the same variable. I will reset it. AG, SGA, old and new value. So I will give AGA 1, add, and SGA 2, add, continue, and OK. Now what it will do, it will convert this AG and SGA into the numeric variable. After this, I can convert this into the numeric. After this only, remember. Okay, and then in the label, I will go here in the values, I will go 1 and I will write down AGA, add, and 2, I will round SGA, add, and I will click OK. So you can see now it is AG and SG again, and this is a numeric, this is a nominal data, numeric nominal data, we can say. So any question? Means you can unmute and ask the question. So the question is that which normality test we should use. So when you will go into the SPSS, it will actually give you both the result, but this KS test is for more than 50 sample, and Sapro-Wilk test is when your sample size is less than 50. This is not a rule of thumb, but yes.
Excuse me, sir.
Yes.
Sir, what is string variable?
String variable, what is string variable? Yes, yes, you ask.
Sir,
Yes.
sir, can you share this data so that we can back ourselves?
Yes, yes, I can share. I just.
This data or any other data. So whatever you have told today, explained today, we can practice ourselves.
You'll
Sir,
just.
this data, please. By mail.
Sir, please share in the chat box. Participants can directly download it from that.
Sir, when should we
Excuse me, sir.
but not able to open?
Sir, SPSS software trial version is not opening, sir.
Dr. Dharmen,
Yes, yes.
please give the details, give the data set and PT.
Hello,
Okay,
sir.
no problem.
Excuse me, sir.
Yes, please tell me.
I want to know when do we use like post hoc test?
Post hoc test is used when we are saying that our data is look, log is something when we are just looking at that our data are equally distributed, means there is no difference into the groups. No, then there is no need of going for the post hoc. There is a difference. We want to see that how much difference is there. Then we are going for the
Thank you, sir.
post hoc test.
Excuse me, sir. So please tell us how we can use different type of tests and where we
I
have
think
to
next
apply. Sir,
after in
please
the
can you
next
tell
two
us one
session
by
you will
one?
get the answer to this question, because testing of hypothesis parametric part day 2 and day 3 is
Can
dedicated.
you repeat the post hoc test again?
Are we
Post hoc,
getting
post
the
hoc again.
recording?
Can you tell the basics of SPSS?
I told a little bit basic of cases in the practical session. How you can just if you remember, I told you that what how this SPSS when you open, how does it look like? It have got a data view just like the Excel. It have got a variable view in which you can explain the variable. How you can explain the variable, that is also is being also explained to you. And when you click, there is more window open that is termed as output variable. The beauty of this output variable is that you can copy from here and paste directly to your Word file also. Okay.
Hello.
So
Good evening,
yeah.
sir. Excuse me, sir. Sir, what does Q2 plot data editor?
Yes.
Sir,
Where is this data
can you explain
editor?
this post hoc? When to use post hoc again? Again, kindly, please. Post hoc. When to use post hoc test?
Tomorrow they will explain you again, because this is a testing of hypothesis portal. I
Sir,
just
excuse me, sir. Just now you told that.
Excuse me, sir.
ask me about describing the data only today.
Sir,
Excuse me, sir.
plot.
नहीं वहाँ तो पास बोलो.
Sir,
Sir, I
excuse me,
have a
sir.
question. Hello.
Yes, one by one, please.
Sir,
What kind of data is appropriate to plot box plot, and how
Yes,
it
sir,
can
my
be
question.
explained?
Yes,
Yes,
sir.
sir.
So
Same question, sir.
any kind of data you can do the box plotting, but if your data is skewed, box plot is more appropriate. Okay.
Sir,
box plot is very
Hello.
robust.
Hello.
Yes.
I want your advice from
Sir, how to do the post hoc test in SPSS?
Sir, how can we explain the box plot, please, sir?
Yes, again.
Box plot, sir. Box plot.
Okay, I'm just telling you about the box plot. Okay. Just
Okay,
go
sir.
to the graph, legacy dialog. Here you can see one girl is asking that how to plot the trend line. You can see this. Okay. So when you click on this line, simple line, multiple line, and drop line. So if you will click on the simple line, so it will ask you what is the category axis and what are the rows. So for this you need the category axis, and for rows you need the year, because we do not have any year. Just I'm putting it the category axis. If I'll click OK, so it will just show you the trend line. Okay. But this trend line is nothing but it is the frequency of 1, 2, 3, like this. Just the age in this like this. Now, how to plot the box plot? Again, go to the legacy plot and go to the box plot and go to the simple box plot. Okay, and summarize of a separate variable and then click define. And I am just selecting this and then I'm clicking OK. So I'm selecting age at admission. Options are here. Exclude case wise, excludes case wise variable. So I am not doing this. Again, then I'm clicking OK. So it's just giving me the box plot for age at admission. Now you can see one is the minimum value and one is the 25th quartile. So 4 is the median. So this line 4 is coming here. And 12 is the third quartile, 11 is the third quartile. So this line is coming here. 1, 4, 11. So 25% of observation are above this 11. 50% of observation are above 4 and 50% of observations are below 4. That is what this box plot is actually showing to us. And this is again the interpretation of the box plot. If I will plot the box plot for another variable, simple, define, and instead of this, I am just taking birth weight of the babies in gram, and I'm clicking OK. So here you can see that what is the distribution of birth weight of the babies into this 67 data. So the minimum value is somewhere around 980 gram, maximum value is somewhere around 3800 gram. The median of this data is around 26. So 50% of the babies are above 26 or 50% of the babies are below 26. 1800 gram is the first file, 25% of the babies are born below. So this is how the box plot is being explained or read off by the reader. I hope I'm clear.
Thank you. Thank you so much, sir.
Thank you, sir.
Sir, I have a request, sir.
Yes, please, Mohammed.
Sir, actually, everybody is asking from a lot of questions from different dimensions. It's getting complicated. Can we follow an order like properly?
Yes, you are right. But today already the session is at the verge of closing.
Right, sir.
Tomorrow onward, I will request the.
Yeah, actually, yeah, in the last way, actually, we take the
Yes, yes. Dr. Yadav. Dr. Yadav, sir.
Sir?
Dr. D.K.
Yes.
Yadav, sir.
Yes, yes.
Please wind up the session, sir.
Yes, yes. We can take the PPT and data set. You can practice and then we will
You
discuss.
can ask
Sir,
through the
sir,
email.
kindly let us recordings as a trial version. We aren't able, sir,
I have shared
to access the trial version.
into the chat box. Data set is there in the chat box.
Send the recording to the mail.
Yes, yes. You will get a set. Yeah.
We send all the details through the email.
So, thank you so much, sir, for your wonderful session. And we have more 6 days, so don't worry. We will cover all the topics. Thank you so much.
Recording stopped.